Now we are moving ahead. The topic, the microstructure development in Fe carbon alloys. So iron carbon alloys, what is the microstructure development? So basically steel, right? FeC means steel. This alloy known as steel. Okay. If they are having less than 2% of carbon content. Here we are just discussing all are having less than 2% carbon. So that's why we can call them as a steel. Okay, so the microstructure of a steel depends on the cooling rate and the temperature at which the transformation occurs. So, I mean, till in a heat treatment process, we have already known that it depends on the cooling rate and the cooling process. I mean, how the microstructure will be, right? So similar thing is here also. That microstructure of steel depends on the cooling rate. At what rate that you are letting them cool, okay, and the temperature at which the transformation occurs, and the different temperatures will define the different kind of microstructures. The following microstructures can be developed during the isothermal transformation. First one is Pearlite. How the formation? The formation temperature is just 550 to the 727 degrees C. Here you can see it is taken into the centigrade. Okay, so don't get confused with that. I mean, if you have just changed the scale, then the numbering, the digit will be changed. Okay, so the value would be the same, but their integer number would be different. Okay, here, it is the 550, or you can say 550 degrees C to 727 degrees C, which is in centigrade, depending on the alloy compositions. How, I mean, what is the structures? The laminar mixture of ferrite, soft, and cementite hard. We know that pearlite is just a kind of the sandwich kind of material where we are having the ferrite and cementite just kept one over another, right, like a sandwich. Okay, so one layer of ferrite, then another layer of cementite. Again, one layer of ferrite, then one layer of cementite. That's kind of the laminar mixtures are basically this is the structures. If we talk about the properties, then moderate hardness and strength, good ductility. Ductility. So ductility is very good. What are the application paths used in the structures, components, and machinery parts? And these are the and I hope that you are aware and you are able to recall that we have already done this part in a previous slides. I mean, in a previous unit, right? What is Pearlite? How they are going to form? What are the structures? What are the properties? And what are their applications? Still, we are having here brief in a brief. So, if you will look, closely, lots of things are just repeating again and again. Okay, for every topic. So, if you have just understood the basic things and the fundamentals, then you must be having a easiness while you are moving ahead. Okay, so lots of things will be coming repeating again and again, like the Bainite. We have already done what is Bainite, how they form, what are the properties, what are their usage. Okay, so formation temperature 252 to 550 degrees C. Okay, structure a fine non-laminar mixtures of ferrite and cementite. Here also we are having both the things, ferrite and cementite, but here not in a laminar. It is not in the form of sandwich. Okay, it's just a normal kind of material. Here anything could be, but this is not like the pearlite in the form of laminar. So here it is not in that way. Properties high hardness and strength than the stronger, you can say stronger than the pearlite with a good toughness. Here toughness is also high. Application part used in the components requiring in the balance of its strength and toughness. Okay, such as a spring and gears. We talk about the martensite. Okay, so the formation of a temperature. I mean, below the martensite, I mean, if you can say what is the MS, MS is the martensite start temperatures, which is less than 250 degrees C. Okay, so structures, a superstructured solid solution of carbon in iron, which are the body centered tetragonal BTC structures. BCT. Properties very high hardness and strength, but brittle. As you know, the temperature will cool down. Okay, and the martensite is just a kind of the material are having the high hardness, and high hardness will lead to the more brittleness. And you can say, or opposite sense, they are having the less ductile. Application part is a cutting tool, okay, knives and components requiring the high wear resistance. These are just example of Martensite. So here we have discussed three kinds of things: Pearlite, Bainite, and Martensite.